A bit about building Gen AI applications, leveraging LangDB and ClickHouse. A little bit about myself. I'm one of the founders of LangDB. I come from a data background, so I'm mostly in both startup and corporate. I've been at part of the early team of DataRobot. I built basically the data platform at DBS Bank, actually, from like early 2017. And before starting LangDB, I was at Goldman Sachs leading data engineering. The company LangDB was started about 2 years ago. Oh, is there? Okay. Company LangDB was started about 2 years ago with a different product, and we more recently, just a few months ago, we pivoted to the focus more on Gen AI, and we are backed by the investors Sequoia, Gradient, and General Capital. All right. So what are we going to talk a little bit about today? So I want to introduce you about the concept of Gen AI application, agents, etc. Something that probably you are quite familiar with. And then introduce the concept of what LangDB is about. It's an AI gateway. Why an AI gateway is useful, and how you can leverage an AI gateway when you build agentic applications. And next, I'm going to focus on why ClickHouse, why we chose ClickHouse as a foundation for our LangDB, but at the same time, how you can leverage LangDB and ClickHouse to build Gen AI applications. And then I'm gonna bring you a couple of examples of stuff we have built using LangDB and ClickHouse, and show you how, give you a quick demo of how LangDB works and how it can be leveraged. All right, so let's talk about a little bit about agentic application LLM tools. If you think about how the agentic application evolved over time, so at the beginning you have the basic usage of an LLM. So you ask a question to LLM, all the knowledge is contained into an LLM, and it spits out an answer based on its internal weights, etc. Then things started to become a little bit more complex, and we started basically getting tools available in the LLM. But the execution of these tools was pretty much fixed. So it's a fixed pipeline where you ask a question, and then you have a fixed pipeline that does some operations in a precise sequence. An typical example is RAG. I ask a question, the LLM doesn't actually know the answer internally, so it basically generates a tool response, and then we fetch some data, we populate this data into the LLM context, and we finally get our answer. Now, the next level of application is what people generally refer to agentic application, is where the path that the application follows is non-deterministic. So you leave to the agent the decision of what to do, and you provide to the agent some functionalities. Like in this case, you provide to the agent multiple LLM, because now it's not just about LLM, but you might want to use an LLM if you need reasoning, you want to use a different LLM if you want to do code generation, etc., etc. And you give the agent multiple tools. So these tools can be getting data from a database, like in the beginning they mentioned about ClickHouse MCP server. That's something where we are working with. But at the same time, this is starting to become a standard. You have a bunch of NCP that you give available to your agent to access information. And the other part is obviously what I was referring to, planning. Planning before was done programmatically through code, now planning is basically left to an agent, which is often a reasoning agent. And that's basically the process that is followed. And this is one example. Like if you ask, summarize the latest AI trends and suggest some expert to follow, this is what a typical agentic application would do. Retrieve some recent AI papers, extract the trends, identify the top AI expert, and based on this contextual information, give you the response. Now, what are we have, during the development of LangDB, we have built various agents. What are the biggest challenges that generally you face when you build these agents? One is the multi-agent complexity. So you start with one agent, but eventually you end up with multiple specialized agents. And if you think in the example below, you might have one agent that requires reasoning that use one specific model. You might have a different agent that does summarization that requires a different model, another agent that does data retrieval. So it's a composition of agents talking to each other and collaborating to achieve the result. Now the problem is if you are used to debug software, traditional software, that's pretty straightforward. But how do you debug an application where you have multiple agents collaborating with each other, and how do you understand the execution flow? This is one challenge that if you start developing pretty complex agentic application, you will start facing. As I mentioned, the integration challenge, this is tools. So we talk about MCP servers. Luckily, MCP came to help in this. So you want to give your agent the ability to access a variety of tools to access data. And that's some tools, I mean, before in the early days, you had to build everything yourself and adapt it to multiple models. Now it has become easier with the MCP protocol, but still you need something that allows you to streamline this tool access. And the other aspect that you can consider them together are dynamic routing and model selection. So as I mentioned, you might need multiple models, but because your agent behavior is not fully deterministic, you might not know which model you need. So
the screens.
Oh. I have to. All right. So you might not know which model you need. So you have to basically decide. You have to have the ability to route to a specific model based on your questions. And the other aspect that is, it's relevant to this is cost control. I don't want to have. Yeah, of course, I can always route to my best model, but if I don't need complex operation, let's say I need to do summarization, do I really want, or data extraction, do I really want to route you to my most expensive model? In this case, I want to use a good model, a model that give me good result, but at a cheaper price. And last but not least is the effort that you have to put in prompt engineering. All right, so having said all this, let's you start to realize why you need an AI gateway. So what is fundamentally an AI gateway? An AI gateway is a piece of software that sits between your agentic application and your models and your tools to give you a single interface to develop your application. So what are the key aspects of an AI gateway? One, logging and tracing. What I mentioned before, you develop this very complex application, you need to be able to trace it, you need to be able to debug it, and you want to have a history of what happened to analyze past behavior. and because this data can also be useful, and later on I will explain, might be useful to fine-tune your model as well. Routing and model selection, you want to have a mechanism that is capable of routing to different models in different ways. One way, as I mentioned, could be a fully automated way, so optimizing cost, for example. But a different way of routing could simply be testing. Let me give you one example that happened. Company has deployed a Agentic application, mostly leveraging GPT, and DeepSeek came out. So they said, okay, we want to try out DeepSeek. Obviously, they didn't want to change their code because just to branch to use DeepSeek, but they could go to the AI gateway and say, route 5% of my traffic to DeepSeek, and later on was able to analyze what was the performance in terms of cost and quality of responses with DeepSeek for that 5%. And they decide to switch all the traffic to DeepSeek, evaluating it without touching their original code. So this is what routing is all about. I have the screensaver. Evaluation experimentation, which goes in bundle with this. When you say, I want to route some of my traffic to DeepSeek, I want to be able to evaluate how good the responses were and evaluate the cost. And this is more like an enterprise level feature, but it's guardrailing and policy management. I want to be sure that no data that is supplied to LLM is leaked outside of the network. I want to make sure that there is no prompt injection, etc., etc. All right, so I want to talk a little bit about LangDB, and LangDB is basically a enterprise AI gateway, and I want to talk a little bit about what we are trying to achieve with this. So we are trying to build the fastest enterprise AI gateway. So there are a couple of, it's a space that is growing and is starting now. Most of the enterprise, I would say all of the gateway available there are either written in Python and or JavaScript actually. So our fundamental idea is that if you put a piece of core infrastructure, and this piece of infrastructure will become more and more important in any enterprise, you don't want something that is not scalable and that uses something like Python or JavaScript. And that's why we took the decision of fully building this in Rust, which compiles to native code, and the performance is basically equivalent to what you get in writing C or C++. We give access to more than 250 models, actually. So you can, with one single OpenAI compatible API, you can basically get access to all these models. We try to solve the problem that I mentioned before of multi-agent tracing. When you develop a complex application, you need to find out what were the interaction, analyze the history. That's what we try to solve as well. And the important aspect is, I think these are the two most important aspects. One is the tracing, and the other one is the routing that can help you improve the responses and save cost. And I'm going to dig a little bit more on that because that's a question that comes up many times. In terms of deployment, it's hosted or on-prem or it's available also in open source. And that's where ClickHouse comes in. All the data that is collected by the AI gateway itself is basically stored in ClickHouse. So you have full access to your data, and we provide analytics out of the box using ClickHouse. So that brings me to my next question: why ClickHouse? So one is, everybody knows here that ClickHouse is heavily used for analytics, is very performant in that, and all the traces that we store, they are basically analytics. We provide a lot of metrics on the LLM usage, and that's the reason why I choose it. Second is the control that this gives to the customer. So we give the flexibility to anybody to say, I have my own ClickHouse, I want to use an AI gateway. Everything should be going to my own ClickHouse. So in that case, data doesn't leave your organization. All the tracing is there. You don't worry about leaking any information out, because this can be there can be a lot of sensitive information there. Now, there is a challenge here that is, I think ClickHouse team is starting to address this, but we had to deal with. So ClickHouse has primarily been designed for structured data and analytical data. What we deal with here is heavily unstructured data, which is actually much more unstructured than what we saw before, like JSON. We're basically dealing with text, okay? So how do we handle it? So the approach that we have taken is basically leveraging the ClickHouse UDF, custom UDF functionalities. This is only available now on-prem, so on the open source version. I know the ClickHouse is launching the cloud version, and we're working closely with them to deploy it, so that will be available there. Fundamentally, what we offer is a simple function that is AI completions. This is nothing more than a function that allows you to call LangDB API to interact with AI models directly from ClickHouse. So the advantage of this is that you don't have to write any Python script, you don't have to write anything. With just a simple function, you can combine structured and unstructured data together to build your application. Later on, I will show you some examples. How you can? There are basically two ways to implement, let's say, the Gen AI application building that we see. There might be even more, but what we encounter so far, two ways of building a Gen AI application together with ClickHouse and LangDB. One is ClickHouse, which is the most common use case. ClickHouse as an MCP server. So you have your AI agent, you have LangDB here that is basically your AI gateway. LangDB itself provides MCP servers as well. So that means that in your agentic application, generally how it works is that in your agentic application, you will have to handle the MCP calls. We handle the MCP calls ourselves, and we basically allow you, we are releasing this very soon, we allow you to create what we call composite model. Fundamentally, you can say, I want to use DeepSeek with this parameter, with this MCP server, with this system prompt, deploy it as a model, deploy it as a virtual model, and when you hit that API, you know that you are using that model, those parameters, those MCP servers available, a pre-packaged configuration. And that's one way. And obviously, as I mentioned, all the tracing data flows into the ClickHouse as well. The second way that I was mentioning is use AI, what we call AI functions. So from your ClickHouse, from your SQL script, so basically you invoke a custom UDF. This UDF interact with LangDB that can call a virtual model or can call any model to process unstructured data. I want to talk a little bit about, because this is a question that comes up many times, and it's in one of our core features. This is a feature that, this particular feature is not released yet. We're going to. So one of the routing mechanism that we have in LangDB is least cost routing. So optimized routing, because you can optimize also by model quality. So Right now we have a router that is capable of automatically routing to multiple models, and the data that is used for the routing is pretty generic, and which is based on LLM Arena. I don't know if you guys know. It's basically an evaluation of multiple models that tells you which model are better based on which prompt. So based on the prompt, we can automatically route to a specific model. But what's interesting is when you start, especially now there is a lot of hype around SLM, small language model, that are specialized model for specific domain knowledge tasks. So what happens is that, and this is a common pattern that people are adopting. I don't know if you guys use tools like Cursor to generate code. If you notice, they have a bunch of generic model like Claude, GPT, and then they have their own model. Now this model is actually a model that has been trained based on users' data. Think about when you interact with these tools, you send your request, you get your code as a response, and you have a huge value when people press accept the code or not, because that's preference data. And preference data is basically your user are automatically labeling the data for you to fine-tune a model. So we follow a similar approach where you say deploy your application using general model and let the user interact with it and try to gather preference data. Once you gather all your data plus the preference data, once you gather all this, now you say, okay, you can use this to fine-tune your SLM. But we not only fine-tune an SLM, but we fine-tune the router as well. So what happens is that the SLM is actually trained using question and answer, and the router is basically trained using only question. The router is fundamentally a classification model. What happens here is that when you deploy this, you get a question. The router is capable to understand if how the question is relevant to your train SLM and automatically route the question to the SLM, which gives you good response at a much cheaper price because we're talking about a much smaller model. How to use it? It's extremely simple. So you have OpenAI API. It's fully compatible. So you basically replace the key and the base URL of your OpenAI API, and you can specify any of the model that you find in the platform. Now, this is not just a model, but you can specify a router here. So I can, instead of hitting directly a model, I can say I want to hit a router, and the router will basically take the decision of what actions to take. Should I route you based on the criteria that you define in the platform? All right, so I want to give you a couple of examples that we did. One, we use it for ourselves. The other one, we did it for fun, especially for this session. So this is to demonstrate the UDF capability. So what we did, we went to the ClickHouse Slack channel and we scrape all the content, okay? So we pull all the messages from the ClickHouse channel, from the support channel. And then we put everything in ClickHouse, and with our UDF, we basically told our LLM, based on these messages, give me all the potential metrics that I can extract from the messages. What we got is like 40, 50 metrics that look something like this. You can see here that I have product issue, the metric name, the description of my metric, a couple of the values, and the prompt then later I will be using to extract the metric itself. And this is where obviously I need to model here. I need a reasoning model to be able to extract the metric because it requires some abstraction, but to extract the metric themselves, I need something that is much simpler. I'm going to run thousands of messages through an LLM. Obviously, I need to get the best and the cheapest. And that's what we came up. So out of all this, this is what we got. I think I have a, well, let me show you. I have this on the ClickHouse dashboard itself. And you can see here that by extracting all these metrics, I categorize what people are talking about, the version that they're talking about, the database engine that they're using, the top 5 cloud providers or people are talking about, how many issues have been resolved in a thread, or how many are still open, the severity of the issue, the deployment type, the top 10 data sources. These are just some of the metrics, just an example, but to give you an idea. And this is, okay, this is a bit long. This is actually the UDF that was, the SQL that was used to do the extraction. Now you can see here that I have, it's quite long actually, because these are all the metrics, but what's more important here is this AI completion. So AI completion basically invokes my model, my LangDB, and I'm basically passing my prompt here with all the metrics that have been extracted. Now here the metrics are passed in line. We should pass the metrics from another table, but that's basically how it works. Let's go back here. All right, so I want to give you a demo of LangDB, but before giving you a demo, I want to give you an overview of the second example that we worked. This is just to show you the tracing capability and debugging capabilities. So what we have built, we have built it for ourselves actually. We needed to promote LangDB actually. So we're trying every possible way to promote LangDB. And one way obviously is social channel, Reddit, Hacker News, etc. And so we say, okay, let's build an agent to let her go. We call it Ramanda. Let her go around and scrape for content. And if the agent finds something that is relevant and that is people are talking about AI gateway, people are talking about competitor products, etc., just comment if it's relevant. And this is what the agent does. It does community monitoring. When it finds a message that could potentially mention LangDB or any competitive product, it tries to understand what people are talking about. It does some research, goes out online and does some research, and it basically evaluates if it's appropriate to comment this message, and if it's appropriate, basically post a comment on Reddit. Now, having said that, you can imagine that, as I mentioned before, building an agent that does all this, it's debugging and seeing the behavior is not trivial. So I want to give you an overview of how LangDB can help in that. So this is like the main screen of LangDB, where you can see these are all my threads. So this is exactly the thread that that has been run by our agent. And you can see here that I have the full trail of logs. So I can see that my system prompt, I have been required to grab some URL. One is langdb.ai, the other one is documentation about LangDB. And then the agent figured out that someone was actually talking about this is the summarization, someone was talking about a competitive product, and then some information was gathered, and at the end, in this case, the agent said, okay, the comment is not relevant, so the message is not relevant, so I'm not going to comment. But here on the right side, you can see the full execution. You can see that the master agent did the initial call, then there was a request to grab some URL. Now, when you grab the URL, obviously, because of context limitation, you cannot put the entire content of a website into the agent context. So what you need to do some summarization. So there is a separate agent doing the summarization. And you can see here that we have a summarization request that is executed in the context of our tool call. So basically, we are basically invoking an MCP server. An MCP server is grabbing the content, and then another agent is taking care of the summarization. So this gives you an overview of what tracing looks like. Now, since I'm here, I'll just give you a very quick overview of what LangDB is about. So here you can have, fundamentally what you have is a playground that allows you to test your prompt. This is an initial important part. So you start, you say, I want to build my agent, I need to test my prompt, I need to evaluate the quality, I need to evaluate decide all the parameters for this prompt. Once I decide that, then I can start implementing my agent. Once you run it, then what you get is all the metrics actually, which are basically here. This you get a overview of all the metrics, your cost, your time, the time to first token, the intra-token time, etc., etc. Whatever you need to do when your application is running. And last but not least, what I was mentioning before is the routing. So you can define a new router. Here I have the different type of router, different policies, and then you can use this router in your API. So I think I basically concluded my talk, and just for your reference, you can check us out, langdb.ai, or the open source version we just released last week. Give us a star if you go there, and yeah, thank you very much. If there is any question.